Hello everyone. This is how we denote the antiderivative of f, capital F. The table from the basic module of useful derivatives is also a table of useful antiderivatives. The antiderivative may be different when considering different domains and always is set up to a constant. For example, the antiderivative of 1 over x is log x on the positive reals and log absolute value of x on the non-zero reals. Sufficient condition for the existence of the antiderivative on an interval is continuity on that interval. Although technically we are integrating with respect to x, we abuse notation and denote the antiderivative as a function of x as well. As an abuse of terminology, we will use the terms antiderivative and integral interchangeably. This is a non-continuous function and we try to find its antiderivative. For each segment, we have an antiderivative due to continuity. However, there is no way to patch these two together and get a differentiable function at 0 as well. Read the following question, stop the video now and continue when you have an answer. The answer is true, and any continuous function which is not differentiable induces the answer by integrating twice. This example is for 6 times the absolute value of x. One technique of solving integrals other than remembering the derivatives of various functions is substitution of variables. We suggest that x is a function of t and substitute x and dx in the integral accordingly. Usually we guess g of t, but sometimes there are known substitutions that work. If your integrand includes square root of a square minus x square, this is the g of t that you should use to replace x. And these are 2 more substitutions that are known to work. If the integrand is a rational function of sine and cosine, we use this substitution, meaning whenever the integrand consists only powers of sine, powers of cosine, and constants, possibly in both the numerator and the denominator, we substitute x with 2 arctangent t. As an example, consider this integral. We use this substitution to get this known integral, and the answer follows. Try to spot this special case when it occurs. The integral is 1/2 f squared. For example, what is the antiderivative of log x over x? It is 1/2 of log squared. We use integration by parts whenever we know the antiderivative of f of x. We use that knowledge to transform the problem from this form to a hopefully easier problem concerning capital F and not f. When g is x, the integral might be even more simple. For example, what is the antiderivative of x sine x? Observe the following calculation. Consider the following example. We use all the relations we know from the basic module. We use the double angle formula and then eliminate the square using the cosine double angle formula and solve the integral. For a rational function, we have a method that always works. We decompose the integrand to partial fractions and then use known simple antiderivatives. We will explain by an example. Consider this integral. As long as the degree of the numerator is not strictly less than the degree of the denominator, we can divide the polynomials as seen in the basic module. The division results a simple polynomial term, in this case the number 2, for which the integral is known, left to deal with the remainder of the division. Now we need to find all the possible real roots and decompose the denominator to a product of degree 1 or degree 2 polynomials. The degree 1 polynomials is in the form of x minus a root, and the degree 2 polynomials have 2 conjugate complex roots. These are called the irreducible factors of the polynomial. Now we continue with the decomposition, and we want to get this form where the denominators are the irreducible factors found before, and the numerators are unknown polynomials, each has a smaller degree than its denominator. We use simple algebra to compare coefficients and find a, b, and c. We can use tricks like plug in the roots, for example, x equals minus 1, or take derivatives to speed up the calculation for a, b, and c. After finding a, b, and c, this integrand transforms to this form, where the leftmost term is known to be the derivative of log x plus 1. Left to show how to find the integral for this. To get rid of the x part, we use the log of the denominator, namely this. Observe what is this derivative and subtract it from our integrand. The rightmost integrand is some form of a derivative of arctangent, which gives us our final answer. Don't worry, the problems in the GRE won't be so intensive calculation-wise. I used this long example to show you various aspects of the method. Quiz. Take 1.5 minutes for this problem. Stop the video now and continue when you are ready. Ready for the answer? It is E. The easiest substitution here is that which solves the integral immediately. We use the given value to evaluate C and then find the answer explicitly.